How are you guys? Welcome back to my channel. Today we're looking at flows in pipes and hydraulic gradient, which is N6 fluid mechanics. Okay, but this is a revision. We have learned about this on our previous N, which is N5. So let's start it. First, the flow in pipes. We have types of flow. We must know types of flow. We have types of flow, right? Types of flows. Good. Then let's start. We have this type of flow which is called the turbulent flow. I hope you still remember this. A turbulent flow. Let us do just a sketch here to demonstrate the turbulent flow. We have a turbulent flow. We know, let's say now we have the turbulent flow. This area indicates the flow, turbulent flow, right? So turbulent flow are particles flow in disorderly manner. They flow in disorderly manner. They don't flow straight, but they flow, in successive, like they don't flow in orderly manner, like in sequence. They flow, they don't follow the same path, but they flow disorderly, which this is a type of flow which we call it turbulent. Turbulent flow is caused by roughness, or is caused by obstructions that occurs in the pipe or in the river. It might be a river. That obstructions they result in a turbulent flow, right? So they don't flow smoothly. You see, when you have a river, water flow like the bounce of when you have rapids, water does not flow smoothly. This we call it a turbulent flow. That is a turbulent flow. How can we define a turbulent flow? So we can simply say a turbulent flow. We know that particles, as you can see, the particles flow in this orderly manner. Particles flow in disorderly manner. They don't flow straight up or in an order manner. They flow, yes, as I depicted here, they flow in disorderly manner. This is a turbulent flow. They flow in disorderly manner, and we know them, and they are occupying flowing disorderly manner, and they are occupying different relative positions in successive cross section, right? Cross sections. You can see cross sections. Cool. We will define what's the turbulent flow. It's a flow which particles flow in disorderly manner and occupy different relative position in successive cross section. We call this a turbulent flow, right? Then we have secondly, we call it viscosity flow, or we can say viscous flow, or we can call it laminar flow. I can say this is laminar flow. We have a laminar flow, right? Laminar flow, it is the opposite of this, because in turbulent, they don't they flow in disorderly manner. But right now, laminar flow, they flow smoothly, which is they flow in orderly manner. Just an opposite of the two. That means they flow in orderly manner. If we can depict the structure here, let's say we have this pipe or a river here. The particles, they flow in orderly manner. You see them, they flow in orderly manner. This one, they flow in disorderly manner, okay? So how can we define this? We can say we know laminar flow is known as laminar flow, or this you can call it viscous flow. This is the one and the same thing. Laminar flow or the viscous flow, right? This already have, if we define this, we know this particles flow in orderly manner. We can say this, the particles in laminar flow, flow or move in orderly manner and retain the same relative position in successive cross section. Right, it's just an opposite of this one. We can say here, particles flow, or can say flow, or we can say move in an orderly manner. So the orderly manner, why I'm keeping saying in an orderly manner, they flow in an orderly manner and retain the same relative position in successive cross section. Right, yeah, this is the types of flow. We can repeat it. Types of flow, we have two here, which is a turbulent flow, and we also have laminar flow. We have turbulent flow, we also have laminar flow or viscous flow. It's the same thing. What is a turbulent flow? Particles in turbulent flow flow in disorderly. What is important is this one, disorderly manner, occupying different relative position in successive cross section. Then laminar flow, particles flow or move in a orderly. This one are in order. They move in orderly manner and retain the same relative position in successive cross section. This is the difference. So you have to know just only these two types of flow. You must know these two types of flow. Then in the next video, we'll look what we call terms used in connection with the flow of a liquid. You must know, like example, uniform flow, steady flow, so on and so on. Thank you.